Lesson 37, Preprocessor Directives. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Preprocessing occurs before the code is compiled, and preprocessor directives are preceded by this symbol, which is sometimes called a pound, sharp, or number sign. In this code we give a simple example of a preprocessor directive using the define keyword. In the first line, we use a define directive to define a value for pi. When the preprocessor runs, it goes through the code and replaces every instance of capital Pi with 3.14159. In the main function, we calculate the area using our defined pi value. To see what the preprocessor does, let's run it on this code. After preprocessing, our code looks like this. Notice that the define directive is gone and our pi is replaced by the constant value. This preprocessed code is what goes into the compiler and becomes our executable. Preprocessed files can be generated with most C++ compilers. The most common preprocessor directive is the include directive, which we have used in almost all of our programs so far. An include directive pastes all of the code from the included file into the file at the location of the include directive. Since the included file may have include directives of its own, an include can greatly expand the code in a file. For example, if we preprocess this Hello World program, it expands to over 50,000 lines of code. That's way too much to look at, but it should give you an idea of what lurks beyond a simple include directive. Another common use for preprocessor directives is making macros. Like the previous define directive, we use a define keyword. However, instead of a simple replacement, a macro acts somewhat like a function. This macro, for example, is used to find the maximum of two values. If we preprocess this program, for example, we get this. Again, the preprocessing removes the define directive and replaces max with the corresponding code. This time, however, the variables x and y that we put in the parentheses are substituted in place for their corresponding letters a and b. Finally, we can use conditionals to determine what code should be compiled. Like normal if statements, we can have else if and else branches. However, preprocessor if statements determine what code will be compiled instead of just what code will be executed. To understand how this works, look at this preprocessor if statement with three branches. The values x and y are defined as 0. So the first two conditions are false and those branches do not get compiled. In fact, the preprocessor eliminates all of that code. Here's the preprocessed version. Notice that the define directives and the if branches are all absent. Only the initialization and assignment get compiled. The rest is eliminated before the code reaches the compiler. This type of preprocessing is particularly useful for developing on multiple platforms, as our next example will show. We give one last example of a program using preprocessing directives. In this example, we define the symbol Windows to be replaced by nothing. The purpose of this is just to tell the preprocessor that the symbol is defined. In this case, we want to indicate that the code is being compiled for the Windows operating system. In the main function, we have an if-def directive. This statement works like an if directive, except that it includes the block of code when the symbol, in this case Windows, is defined. If we preprocess this code, the code inside the if-def block is included for compilation. We can also use an if-not-def directive to specify code that is compiled when a symbol is not defined. Here we have added an if-not-def directive. Notice that we have an n after the if, unlike the if-def directive. In this block, we would put code that would be compiled on a non-Windows platform. Since we have defined the symbol Windows, this code does not show up when we preprocess it. However, we can undefine a symbol after we define it. We can use undef to tell the preprocessor to stop a code substitution at a particular point, or in this case, we let the preprocessor know that the symbol is no longer defined. Adding the undef directive before the if-not-def directive makes the condition true, so the code in this conditional will now be compiled. This concludes the lesson.